for this investigation, you are going to have things such as an x variable, and you are going to have things which are a y variable. The first thing you need to do for any of the IDUs is to insert a chart. This is my chart. Now with the chart, there are several things we can do with the chart. These are what you can do. You can do the intercept, the slope, and then Pearson. Then you can use these together to substitute. You can talk about the accuracy using Pearson. So the intercept, you use the function intercept, you select the y function, then you select the x function, and you can see how we've got two dots between them. Press enter. The next one we would do is the slope. So again, you select the y data, then you select the x data, and then you press enter. Pearson, you select the y data, comma, the x data. We can then bring these together into an equation of a straight line. I'm going to mix up the values a bit because these are a bit boring. So let's say 2.2, 6, 6.3, 12.4, 15.6. So if we were to create an equation of a straight line, let's say this is 17 instead, and let's say this is 4. That's better. What we would say then is our equation of our straight line is y equals mx plus c, so that's going to be 0.59 x. So y equals 0.59 x plus c, which you can see I've mixed these up. It should be the other way around. It should be the slope x plus the intercept, which is 0.59. This would give us the equation of the straight line. You could then do what it means to substitute in practice. When we are substituting, we are going to take a random value of x. So say if we wanted to see what happens beyond this value 8, let's say if we wanted to see what happens at 10, we can replace 10 into this formula. 2 times 10 plus 0.59, that would give us the equivalent value of y. You can talk about how accurate these are on a straight line. The Pearson is between -1 and 1. If it's closer to 1 or -1, it's going to be more like a linear model. That is one thing you can do for this. Now, if you can't do cumulative frequency, I would do this for a multitude of graphs. I'd also explain what this means in practice in terms of your analysis. So let's say this is to do with, let's think of a continuous variable. This could be height, or this could be the height of a particular animal, and this could be the weight of a particular animal. Now let's say I change the variables to 2, 5, etc. Now what you could talk about is how this straight line has a limitation in terms of the accuracy. The reason why is if you have something which gives you a negative intercept, this would give you a negative weight. So you can talk about how, although you've modelled it with a straight line, there are limitations in the model because the intercept, for example, would give a negative weight. Also, you wouldn't be able to do this for a height of 0. It just wouldn't work. So those are the kind of things you can talk about. Another thing you can talk about is how, as well as the substitution, we've done that, we've talked about this in practice, we could talk about how the gradient works in practice. The way a gradient works in practice is for every one step horizontally along the axes, For this particular thing, we would move up 2 steps vertically. Another thing you can do for the analysis is you could do the average of the data. So you could talk about averages using this formula here. You could talk about the standard deviation. I talked about this in one of the videos. Standard deviation, or standard dev, or I think it's STDEV, will give you how much on average they vary. So if we were to do the standard deviation, we would type in this STDEV of these particular values, and they talk about that from the average, each of them differ on average by 5.2. So this is called the standard deviation. You can look at that online a bit more. And the average would be the mean, or you can just type in the word average, not maverage. The average of all these values. So we're going to say the average value of this is 9. That means the average weight of an animal is 9.5. And if we said that they were all 9, so if we found this on the graph and we drew a straight line at 9, we're going to say that the average distance from the line of 9 is going to be 5.2249. This helps analysing straight lines. This is not helpful for the exponential video or the exponential graphs.